Now working on this challenge called neatx2-rsa, and it gives us two files to download: the main.py file and the rsa.txt. So let's take a look at the rsa.txt. So it just gives us n1, n2 plus n1 times elusive, and ct and ct2. So let's see what main.py does. So first line just reads file, and then the second line just splits the flag in two. And then it just generates 3 primes p, q, and r, and then n1 will be the p times q, and then n2 will be q times r, and then e will be 65537, and elusive will just be a random 4-digit. Yeah, just a random 4-digit number, and then pt will be the integer representation of the flags, and then ct will be the power of pt to the power of e modulus n1, and then we can write them here in n1 and 2. We can write all the stuff in the rsa.txt. So what we can infer from this is that n2 plus n1 times elusive is equal to elusive times p plus r times q. So put this in parentheses and then times q. And then yeah, so we now have n1. Let's crack the n1 first, and we need to find the p and q. So we could just basically need to find the multiplicative inverse function in Python first, and then we'll paste this here, and then we'll have the n is equal to this number. Set the variables. E is 65537, c is this, and then p, q. So let's plug this into the factor db. So, and then we get two numbers. So let's set this number here is the p, and then this number back go here. This number would be the q. And then let's find phi. So phi, let's also set a flag variable, because there's two parts of flag. So flag equals this, phi equals p minus 1 times q minus 1. And then d will be the modular inverse of e and phi. N will be c, d, n, c to the power of d modulus n, and then flag 1 will be the hex, so message convert to hex, and then decode to bytes, and then alright, so let's save the file and let's run it. And then so we get the flag, so to the first one. So, and then we need to decrypt the second one. So we know that the second one is equal to the r times q, so we need to try to find r. So let's use this equation to find r. So maybe we can divide by q to get elusive times p plus r. So let's set this value as x, and then we can get y will be x by q, get elusive times p plus r, and then so let's see how we can get r. So we see that p times elusive plus something plus r. So maybe r is remainder, and then maybe we can use modulus, since maybe we can p times elusive, that can be divided by p, and then add something, and that can't be divided by p. So maybe modulus p, we get the thing that can't be divided, and the remainder that gets added on to to the equations, and then we'll get R. So we'll set R as the modulus P, and then we need NEC. So N will be R times Q, and E we already have. We need C now. So this is the second C. So now I have NEC, R, and Q. So that's enough. Now we need to find phi. So remember, P will now be replaced by R. So it will now be R times 1 because it's R times Q instead of P times Q. So P will be replaced by R, and then it's times Q minus 1. And then D will be the modular inverse, psi, and then M will be C to the power of D modulus N, and then we can flag 2 will be by have M convert to hex, get out the first two parts, 0x, decode, flag. Let's get the flag. Okay, so we've just got the flag, and let's submit it to the bot. Yeah, that's the flag. The bot's just kind of slow. So, yeah, we've just solved the neatx2-rsa challenge.